This is Christine Johning in Lab M05 with my Lab 11 Child Swinging Lab Report. My objective was to model a swing in motion and determine the velocity, momentum, stretch of the rope, and the forces acting on the mass. The main result was that the greatest velocity and momentum occur when the object is moving, not at the point with the highest Y position. The greatest stretch of the rope occurs at the lowest Y position. Gravity is comparative to the parallel net force, and the spring is comparative to the perpendicular net force. I analyzed the video and tracker. The axis is set and the calibration stick is based on the length of the cross support of the swing set. The clip runs for a total of 4.4 seconds. Here is my code. When I set it up, it will update the velocity, momentum, stretch, and the forces. I included the mass of the child and the starting position from the tracker data. I found the spring stiffness and the unstretched length of the spring. This is how the code runs. The black arrow is the total net force, the red arrow is the perpendicular net force, and the blue arrow is the parallel net force. When the ball reaches the maximum Y position, the velocity approaches zero. The velocity increases or decreases while in motion depending on the direction of the ball. The X component follows the same pattern as the Y component. There is a greater change in momentum when compared to velocity. The magnitude of momentum is due to the large mass rather than a large velocity. The Y component is more important than the X component in terms of stretch. The lowest Y position is also the furthest from the origin. This implies the stretch is greatest because it has the greatest force of gravity acting on it, causing the greatest stretch. As the Y component gets smaller, the stretch does as well. The parallel component of the force increases at the maximum Y position. Gravity tries to pull the ball back down at this point. The perpendicular component of the force increases at the lowest Y position because the string tries to pull the ball back up. The parallel component is related to the force of gravity, and the perpendicular component is related to the force of the spring. If drag were accounted for in the code, it would change the motion, but a very small and nearly unnoticeable amount. It is so small because the small speed and non-air resistant makeup of the human body do not allow it to change much, and drag would be included in the net force. Thank you very much for watching.